Hello everybody, thank you for joining. This is the introduction to architecture in the energy industry, the first in a series of energy enterprise architecture training videos. The first topic today that we are going to cover is an overview of the energy industry and architecture, and I am your presenter. I'm Eamon McCormick, a long-time energy architect with over 25 years of experience in the field, working for large energy companies globally. The first question is, what's driving the energy industry today? That there are the three Ds are driving energy today. That is decarbonization, digitization, and distributed energy resources. While there are other drivers, such as an aging workforce within the energy industry, the primary drivers are these: decarbonization, digitization, and distributed energy resources. In the book, The 21 Lessons for the 21st Century, we can see that there are really 5 types of main challenges. There's the technological challenge. The energy industry is facing immense technical change. The second is the political challenge. There is need to move rapidly towards decarbonization, but the political landscape is very uncertain, and it is difficult to move aggressively in many areas on decarbonization due to that. Number 3 is a lot of folks are very despairing due to the state of the economy, COVID, and the challenges of climate change. So we need to manage the fact that there's a lot of hope and despair out there, and that's true in the energy industry as well. And then we need to understand what is truly happening out there. There's a lot of misinformation, there's a lot of confusion, so it is incredibly important for us to focus and be very clear about what's truly going on in the energy industry and what needs to change. And we need to build a more resilient future. With climate change, with the political challenges, we need to make sure that we institute an energy industry in the future that is robust and can serve the needs of future generations. So we're in an incredibly challenging time for the energy industry. We're moving away from a centralized industry based on fossil fuels that has worked for approximately, 120 years or so, and moving now to a much more decentralized world, decarbonized world, and digitized world. So, what does all that mean? When you look at the digital business and the digitization driver for the energy industry, it's incredible how many digital drivers there are. But these can be broken down into 3 essential drivers, which is electrification and digitalization, intelligence, which is the growth of AI, and then the whole idea of the emerging of the real world and the virtual world. So these 3 mega trends are shaping the energy industry in significant ways, and they are a huge challenge and a huge complexity, and all of our clients are completely, it's really quite incredible how much all of these changes and how many players are involved. As you can see, one of these trends is the growth in artificial intelligence. Artificial intelligence is probably in the long run one of the biggest drivers of how the energy industry is going to change. But for right now, we're seeing it just ramping up. Worldwide revenues in AI are just exponential. So we see that as a huge trend in the future that's going to have a huge impact on the energy industry. Along with that's part of the digitization of the 3 Ds. Technological digitization, DER is driven by technology, and then we have the need for stabilizing the climate, which has got to do with decarbonization. So what's the goal? The goal is actually, I think for many people, the goal is fairly clear. We want a energy resilient economy that is distributed, clean, affordable, resilient, equitable, and safe. So there isn't actually a ton of dispute about what the end state is going to be, but there's tremendous uncertainty about what exactly that end state, how to do it, how to get there, and how to do it efficiently, and how to do it in a way that accelerates the decarbonization. So I think there's fair understanding that we want a clean, affordable, resilient, equitable, and safe and resilient energy system that is pretty distributed. It's a huge transition to get from here to there. And on top of that, we have this thing called the greenhouse effect. Due to the burning of fossil fuels, we have this effect of the greenhouse gases are trapping energy, and that means that essentially the planet is warming up. This has to be reversed. It has to be slowed down first, and then it has to be reversed. But this is an overriding challenge of the industry. We're not just looking at economics, we're not just looking at technological change, we're looking at the impacts of the greenhouse effect and the fact that the energy industry is a major driver of that phenomenon. So decarbonization, and digitization all mean action. It means that energy companies globally are strengthening carbon reduction commitments. They're looking at transforming comprehensively across the organization. They're engaging customers, technology partners, peer utilities and regulators early and often. They're integrating equity to ensure all the community members can participate, and everyone's looking to embrace clean energy. These are huge changes and they are transforming the industry. So where does architecture play in all this? Why is architecture important? Well, first off, what is architecture? Well, according to Jeff Taft at PNNL, it's basically the structure, behavior, and essential limits of the system. As we are transitioning from the current state of the energy industry based on 3Ds to a new target state, it is important that we have a very clear understanding of the structure and the behavior and the essential limits of the energy systems. IEC 4210 basically says very similar thing. It says that architecture is all about the fundamental properties and concepts of the system and its relationships and principles and elements. So as we're moving to the new energy architecture, it's clear that we need to understand how all of these elements are, how they relate to each other, and what the properties are. And as the Oxford Dictionary speaks to architecture, it talks about it's the structure of something. So architecture, the goal of architecture is to define the structure of the future energy system, the structure of where we are today and how we move from one to the other. And of course, architecture is also a discipline that's going to help us get there. So we feel that architecture is a really important mechanism of getting us from here to there in this incredibly important endeavor that we're on. The focus of architecture for most energy companies now should be addressing the 3Ds of decarbonization, digitization, and distributed energy resources. That's where the core focus is. But it also has other benefits, such that it reduces good architecture reduces IT costs, improves satisfaction, and very importantly lowers the risk of mission critical system failures. We need a more resilient grid, and it's a mission critical system, so we need to make sure that we do it in a very thoughtful and architected way. So as we discuss architecture, let's go back here and talk a little bit about what is grid architecture. So as we go through here, we can talk about grid architecture. Grid architecture is something that's been developed globally, but it's been primarily driven by PNNL, which is the Pacific Northwest National Lab. What they're basically doing is they have defined a way for thinking about the grid at its largest scale, aka the grid as a system. It includes utilities, customers, market participants, regulatory structures, market structures, control structures. It includes operations, planning, markets, and digital superstructures. This is very important because it's really important for everybody to start getting a vision of where the grid, as the grid of all energy, fits. This is tremendously important because, especially as we're moving towards electrification, electrification works off of one physical grid infrastructure, and it's very important to understand all the different layers of technology, physical, regulatory, control, markets. So all of those things are very important. The next aspect of grid architecture that's very important to understand is the link between grid control and grid and markets. In the energy industry, we have the physical control and we have the market control. It is very important to understand that we need to join both the economic, the market, the social, and the grid control, which is the physical control in real time of the equipment. So it's quite a unique and quite a challenging thing because we deliver energy in real time and it involves the physical instantaneous delivery of power. The other point is that the industry model is important in grid architecture because there's a lot of players doing a lot of different things, and it's important to know who's who and who's doing what, and most importantly, how those relationships are changing over time. What you're looking at here is the European industry model, which comes from the ENTSOE. It's important to understand that there is an industry structure, there are people playing roles, and it's important to understand who's who and what the roles are. This is becoming very important, especially as roles are changing rapidly in the ecosystem. The other key aspect of energy architecture is what process do we use within the enterprise to do architecture. We recommend that using TOGAF because TOGAF is the Open Group Architecture Standard and is pretty much the framework in use in the Global 50 companies and the Global Fortune 500 companies. Using a standardized framework is key because as we execute architecture, we want to make sure we're doing it in a consistent and best practice fashion. And that's where a standard and an architecture standard comes in, and that's where we're going with TOGAF. TOGAF is basically a framework that takes you through a process of visioning, architecture, transitioning, migration planning, managing, and governance. The process itself is actually fairly straightforward. You've got to basically get the organization committed and involved in the architecture journey, focusing, as we said, on the 3Ds. Then you've got to basically get the architecture right. What does the future target state look like? Then you got to make sure you have a plan to get there and make it work. And then you've got to keep the process running and govern it. So TOGAF is a pretty straightforward and intuitive way of approaching architecture in the energy industry. Executing it is challenging. When you look at the way they recommend doing architecture in TOGAF, it essentially says you've got to look at it at 3 layers. The strategic layer, the segment layer, and the capability layer. These are 3 interlocking architectures, and you can think about it as this shown here as kind of a hierarchy. You start with the enterprise at the very highest level. You have grid architecture, which informs the strategic architecture. The strategic architecture breaks down into segments, and the segments breaks down into capabilities. So that's why we're going to start talking about segments. What are we really talking about in terms of segments when we're talking about the architecture in the energy industry? When you look at the smart grid plane, this is a model that's used by NIST and by the smart grid architecture model in Europe and many people to conceptualize the energy industry. What it consists of is a set of domains starting with generation, transmission, distribution, DER, and customer. And then you have the field, the station, the operations, the enterprise, and the market, which are called zones. So you have this confluence of domains and zones with the physical happening down there at the process level. This is very important because it's a way to think about structuring your architecture based on a predefined and agreed upon structure. So as you can see, what we have in the NIST model is you have the generation domain, the transmission, the distribution, the DER, and they cross from the process field into the station level. And then you have horizontal domains, which are focused on operations, enterprise, and market. We've found that this is a very good way to think about the idea that you've got vertical domains, and then you've got these horizontals, and then you've got these zones, which are process, field, station. While this isn't architecture per se, it's a way of organizing your architecture, which we think is very, very important. So organizing your architecture is very important. So that just brings us back to, we are thinking about the architecture in terms of strategic segments and capabilities per the TOGAF. And we're thinking about figuring out what are the key segments in the energy and utility industries. So obviously, the generation is key, the transmission and distribution is key, the customer and retail is key, and we also now have other utilities coming in and interlocking with the electrical grid, which is like, for example, water and distribution, natural gas transmission and distribution, and things like hydrogen gas and transmission and distribution. So it's really important from an architecture to think about the key segments in the industry, and that there's going to be different architectures for each of those segments. So taking what we have thought about in segments, you take the smart grid standards, you take the TOGAF best practices, and then you take this idea of segments, and that drives you to having a basic model for how you're all going to organize your architecture. And this is an example of how to think about organizing your architecture, which is you've got the segments broken down into a strategic segment, you've got segments associated with the domains in the SGAM or the smart grid plane, and then you've got the horizontals like assets, IT, and finance. So this is all, hopefully that's understandable, but this is very important that as we're introducing the topic, that we want to organize architecture as well as we can. Strategic segments, transmission segment, distribution segment are good examples of segments, and then you can further break down those segments into their capabilities. So for example, capabilities is a good example of a of a capability within the transmission segment, or grid operations, for example. So in summary, what we end up having is we end up having the domains, which are generation, transmission, distribution, DER, and customer. We've got our zones, and then we've got different types of architecture, which is business architecture, we've got data architecture, we've got application architecture. So now we have the different types of architecture, which you can conceive of as layers sitting on top of this framework. Remember, this is how we're organizing the architecture. It is not the architecture itself. Some people think that organization is architecture. Organization is important to architecture, but it's not the full story. But this is a good standardized way of organizing your architectures. The other key idea is that as we're looking at certain things now, we can take this framework and try and start understanding where we are in the energy architecture landscape, and what type of protocols, what kind of standards, what kind of data models, what kind of services, what kind of business models are applicable within that area, and this being an example of a virtual power plant. So in this video we have talked about what is architecture, what's driving architecture in the energy industry, why energy architecture is so important right now, and how to organize energy architecture into segments and how to relate them to each other. In follow-up videos, we're going to talk more about the grid architecture, strategic architecture, segment architecture, and capability architectures. We're going to talk about some examples in the specifics of the energy industry. But for today, we just want to finish it with that, and hope you enjoyed this presentation. And look, thank you for your time.